Let's address the elephant in the room. If you live in this circled region right here, you're probably fully convinced it's never going to snow again. And I mean really snow, like the big time blizzards that just seem impossible nowadays. I'm a degreed and professional meteorologist. I was born and raised in the Northeast, and we're going to investigate how true this claim actually is and talk about what has changed in the last 10 years to where we just cannot seem to buy a snowstorm. First, let's crunch the numbers. In a typical winter, Boston should see about 4 feet of snow, New York City 30 inches, Philly 2 feet, Baltimore 20 inches, and DC just over a foot. But if we take a look at the last 10 years, you can see that all 5 cities have considerable snowfall deficits, and it's not something that's skewed by a few very bad years. Most of the years have been below the mean. But what's interesting is that if you go back to the previous 15 years, all of those cities had above average snowfall, including some of the most legendary snowstorms that we have ever seen. But it's not just the amount of snow that's been lacking in recent years, it's the big snow, and the data backs it up. In Boston, the last time we had a 6-inch snowfall was late February 2022, which is the second longest streak on record. In New York City, you have to go back to late January 2022, which is the 5th longest on record. In Philly, that streak is about to hit 5 years, mid-December 2020, and that is the 3rd longest on record. And in some parts of the Atlantic, you have to go back to 2018, but what's interesting is that both Baltimore and DC broke their streaks earlier this year, which goes to show you that there is a luck factor in play. When it comes to the monster 12-inch snowfalls, in Boston, we have to go back to late January 2022, New York City, early February 2021, and Philly, Baltimore, DC, nearly a decade to the blizzard of 2016. Now let's talk about the why. What exactly has changed in the last 10 years? If we take a look at the average winter pattern over the past 10 years, it tells the story pretty clearly. As you can see, we have had a big area of high pressure south of Alaska, which has caused the jet stream to come down into the western U.S., specifically the Pacific Northwest to the upper Midwest. This has meant that the East Coast has predominantly been under a southeast ridge, which tends to be a mild signal. As you can imagine, milder weather tends to decrease the chances for snow. This has also caused the mean storm track to shift more to the west, meaning that if we do get a snowstorm on the East Coast, the heaviest snow bands tend to be more inland. If we look back at the snowy period 2000 to 2015, you can see there is a huge contrast. You can see that the high pressure in the Pacific is displaced more to the northeast, which causes the trough axis to come down over the eastern U.S. You can also see a prominent signal for a Greenland high. That led to both colder and more active weather, which produced many nor'easters. Now, that by itself does not tell the full story because weather is constantly changing and we oscillate between colder and warmer patterns, but it does show you that the warmer regimes have clearly won out. The main culprit, I suspect, is actually sea surface temperatures in the Pacific, specifically this red blob up here. This up here is a marine heat wave, and the blues are cooler waters, and that represents the negative phase of the Pacific decadal oscillation. For the 2000s to the first half of the 2010s, this was actually reversed, and we were in the positive phase. But then, in the late 2010s and continuing to the 2020s, we have settled into this negative PDO regime. This is significant because it does alter circulation patterns in North America. The tendency during this negative PDO regime has been to send the jet stream into the western U.S. and keep the eastern U.S. mild under the ridge. Now, the other big thing that comes to mind is climate change. Now, climate change is absolutely real, and when you combine that with the urban heat island effect, we have seen the average temperatures increase, which by default make it harder to snow. Remember, when it comes to climate change, it's not about day-to-day weather variability, it's about long-term trends. This is most pronounced during marginal events, aka when temperatures are right around the freezing mark. The best way to think about it is if you go back 50 years, you may have had a snowstorm at 31 degrees, but you have the exact same track today in a warmer climate, and it could be 33, 34 and raining. By the way, this isn't just the East Coast, but pretty much the entire United States has seen a long-term reduction in snowfall as temperatures have increased. The last possible factor, could it simply be a matter of luck? And I suppose it could be good or bad depending on your opinion of snow. And I think this snow forecast, which came out this morning, tells it all. You've got one storm tracking to the south, bringing a good amount of snow to West Virginia and Virginia for the second time this week, and then the second one ends up far to the north, dumping snow in northern New England. And right in between, which covers the circled area from DC to Boston, nada. When it comes to storm tracks, there is always some degree of randomness, and in recent years, we have had big storms in places like Tulsa, Austin, Little Rock, Nashville, New Orleans, even the Florida Panhandle. But it really makes you think that if places like that can get big snowstorms nowadays, then surely it's only a matter of time until the streak is broken. Hope you guys enjoyed the video, and if you're a snow lover like me, let's hope that better days are ahead.